Radio astronomy is the study of celestial objects using radio wave emitted from space. Unlike optical astronomy, which observes visible light, radio astronomy uses radio telescope to detect signals from stars, planets, galaxies, pulsars, and quasars. It can observe regions hidden by dust and gas clouds and detect objects that cannot be seen with visible light. Radio astronomy also helps scientists study the cosmic microwave background and provides valuable information about the origin, structure, and the evolution of the universe. In 1932, while studying radio signals, Carl Jansky detected a mysterious source of static that repeated every day. After careful investigation, he discovered that the signals were coming from the center of the Milky Way. This became the first detection of radio waves from outer space and marked the beginning of radio astronomy.
Today, I will explain about radio telescope and radio astronomy. A radio telescope is a type telescope that detects radio wave coming from space. Unlike optical telescope that use visible light, radio telescope collect radio signal that cannot be seen by the human eye. The telescope uses a large dish-shaped antenna to gather radio wave from stars, planets, galaxies, and other objects in space. These signals are amplified and processed by computer to create image and scientific data. Radio telescopes are important because they can observe objects that are difficult or impossible to study using ordinary telescopes. They help astronomers investigate black holes, pulsars, distant galaxies, and clouds of gas and dust.
Radio telescopy works in three main steps, which is collection, amplification, and interferometry. First, large parabolic dishes collect faint radio waves into space and focus them into feed horn. Next, ultra-low noise amplifiers and super heterodyne receivers strengthen these extremely weak signals and boost them into millions of times while reducing noise. Finally, interferometry combines signals with multiple antennas. Using techniques like VLBI, astronomers create a virtual telescope with much higher resolution than a single dish. So, these principles allow radio telescopes to observe distant objects and uncover more details about our universe.
Hello, I'm Atira, and now I will be explaining about a pulsar and quasar. So, what is a pulsar? So, a pulsar is a rapidly rotating neutron star formed after a massive star explodes in a supernova. It emits beams of radio waves from its magnetic poles. As you can see in the slides right now, these are the examples of a pulsar. Very, very pretty. Now, I will talk about the characteristics of it. It is extremely dense. The mass is greater than the sun compressed into a small sphere. And it rotates very quickly, from milliseconds to seconds per rotation. And lastly, it produces regular radio pulses detected on Earth. So now, what is the importance of this in radio astronomy? So pulsar used as highly accurate cosmic clocks. It helped to test theories of gravity and relativity. And it provides information about neutron stars and stellar evolution. Next, I will talk about quasar. So what is a quasar? A quasar is an extremely bright and distant active galactic nucleus, AGN. It is powered by a supermassive black hole at the center of a galaxy. As you can see in the slides right now, I've put pictures of a quasar, which is very different from a pulsar. So now the characteristics of a quasar. Among the most luminous objects in the universe, it can emit enormous amounts of radio energy, and it is often billions of light years away. So what's the importance of it in radio astronomy? So quasar can help to study the early universe, provides information about galaxy formation and evolution, and is used to investigate supermassive black holes.
Cosmic microwave radiation, or CMBR, is a faint microwave radiation that exists throughout the entire universe. It is often called the oldest light in the universe because it was produced shortly after the Big Bang. About 318,000 years after the Big Bang, the universe cooled enough for the light to travel freely through space. As the universe continues to expand, this light changes into microwave wavelength, which we now observe as CMBR. CMBR is very important in radio astronomy because it provides strong evidence for the Big Bang theory. By studying this radiation, astronomers can learn about early universe in age, structure, and how it evolved over time. This radiation was discovered in 1965 by Norman Pensar and Robert Wilson using a radio antenna. Cosmic microwave background radiation is the remnant radiation for the Big Bang and helps scientists understand the origin and evolution for the universe.
In conclusion, radio astronomy has greatly improved our understanding of the universe. By using radio telescope, scientists can detect objects such as pulsar, quasar, and galaxies that are difficult to observe with visible light. These discoveries has revealed important information about the origin, structure, and the evolution of the universe. As technology advances, radio astronomy will continue to play a vital role in exploring the mysteries of space.